This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. When you go on a trip, you probably try to bring everything you think you might need, which might end up being a lot of stuff. NASA has traditionally had a similar approach for the International Space Station, which means that the vast majority of parts stored on the station are never used and take up a lot of extra space. Tracy Prater, a materials engineer at the Marshall Space Flight Center, says there are 29,000 pounds of hardware spares and replacement units on the International Space Station and another 39,000 pounds on the ground ready to fly when needed. Well, that's a lot. And since sending a pound of cargo to low Earth orbit currently costs about $10,000, NASA is looking for ways to lighten the load and reduce costs. This has led to using the International Space Station as a test bed to demonstrate a way of manufacturing the necessary parts in space using 3D printing. Called In-Space Manufacturing, or ISM, the objective is to develop technologies and processes to enable an on-demand manufacturing capability during long-duration space missions. Here's a little more about the process of printing plastics using a device called the refabricator.
The In-Space Refabricator. While 3D printers are technology that many people are familiar with, there's one 250 miles above us on the International Space Station, or ISS, that's unlike anything currently found on Earth. It's known as the Refabricator, a hybrid 3D printer that can recycle its hard polymer plastic numerous times to make new items. About the size of a dorm room refrigerator, the device is controlled by operators on Earth who oversee its manufacturing via video cameras. Nikki Werkheiser, NASA's In-Space Manufacturing Manager at Marshall Space Flight Center in Huntsville, Alabama, says, "Recyclers on Earth grind plastic pellets to create their products. But that grinding creates material shear, which prevents you from reusing that plastic again. It's no longer strong enough." For this technology demonstration, the company, Tethers Unlimited, developed a novel recycling process that doesn't require grinding, and that allows us to recycle the plastic multiple times. The ability to reuse the plastic over and over again is essential for long-term space exploration. Werkheiser says, "We can replace a lot of the things we need when we're orbiting above Earth. We just have them delivered on a resupply mission. But when you're in deep space, you don't have that option. You have to have the ability to make all the parts you might need and without having a large stockpile of extra materials." The refabricator can even recycle plastic items not normally associated with Earthbound 3D printers. For instance, almost all of the materials that are delivered to the station are packed using foam or plastic bags. Both can be loaded into the refabricator to deliver items such as a plastic syringe, an eating utensil, or a custom-made wrench. That ability limits the amount of backup materials you need to take with you on a long-range expedition. After all, in space, space is at a premium. The refabricator's technology demonstration will be composed of 2 phases. During each phase, the refabricator will perform 7 cycles of recycling and printing parts while on board the ISS. All of the items printed by the refabricator will eventually be sent back to Earth for testing and analysis to determine the effects of repeated recycling on the material properties of the plastic. Werkheiser notes, "I'm very excited about this technology both in space and back on Earth. I can envision a day where you go to the grocery store and drop your water bottles and plastic bags into a refabricator and then select your new phone case or a kitchen gadget or the raw filament that you can use in your 3D printer at home."
Now, because many of the parts needed on space missions are aluminum, titanium, and steel, NASA is also working with a number of small businesses to develop metal printing capabilities for this space station. The European Space Agency talks about one such method.
The laws of physics are tough. For centuries still, reaching space will cost a tremendous amount of energy. Hence, the best material to use in space is the one that's already up there. Before we can recycle satellites or even turn debris back into sustainable resources, we need first to learn how to melt metal in space without any gravity. To learn how we can print metal parts in space and validate the additive technology in microgravity, Airbus and its partner are delivering to ESA the first in-orbit metal 3D printer. The challenge there is to operate this technology demonstrator in the International Space Station. Safety first, with pollution and heat containment, and with all the volume, mass and energy limitations. Printing metal at over 1000 degrees will be a world premiere. The printer is ready. It is the first step to bring next space closer. It's here, it's now. Worlds without act or dreams. We are building the future.
And now NASA is moving forward with multi-material fabrication with printed electronics. This allows them to develop and characterize stronger types of materials and processes using various metals, plastics, and digital electronic inks to enable fabrication of hybrid parts and components. This includes embedded electronics, which in turn greatly increases the range of applications and uses for on-demand part production. The current areas of focus for multi-material fabrication and printed electronics applications include radio frequency identification sensing, flexible sensing for crew health monitoring, structural health monitoring, and power generation. Tracy Prater has a motto for the project: make it, don't take it. She also said perhaps the most exciting part of 3D printing for space missions is that you don't necessarily know what you might need to print. Manufacturing enables you to create your own solutions. To me, this is the crew safety enhancement. After all, where would Star Trek Enterprise be if Scotty couldn't make anything? And she's right. Scotty would just have the replicator make whatever he needs. So beam me up. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.